Okay, so first I'm going to have you do is on our calculator, you can either follow along up here or just do it yourself, but I'm going to graph. I'm going to try to graph y equals x cubed, and I'm also going to graph y equals the cube root of x and see how they compare on our graphs. So x cubed and cube root of x. So there is y equals x cubed. There is the cube root of x. So if I zoom in and see how they're related, what could we conclude with these two functions? They are blank. What would they be? See if you remember anything from last year. I will fill in the blank for you. These two functions are inverses of each other. Remember, inverses, they're symmetrical with the line y equals x. So here's y equals x, and you can see that if you folded it across y equals x, it's going to land on the other one. So we already knew that x cubed and cube root of x are inverses because it's the opposite of the operation. Okay, so just like if I graphed y equals x squared and the square root of x, those are going to be inverses because they're the opposite of each other. Alright, because if we did, like, if I had 5 cubed and I wanted to undo the cube, I could take the cube root of this and we're just going to be left with 5 on the inside. Likewise, if I have the cube root of 7 and if I want to undo the cube root, I could just cube it and you're left with the inside, which is 7. Okay, so I just used the cube root and cubed as an example of two operations that are inverses of each other. That's not anything new. What's new though is we've been dealing with exponential functions in this chapter, exponential growth and exponential decay. If I wanted to figure out what the inverse of y equals 3 to the x is, well, this is an example of exponential growth because the 3 is bigger than 1. It's going to grow like this. And up to this point in math, you have not even dealt with something called a logarithm. So 3 to the x is the inverse of it is the log of x base 3. So here on our exponential, our base is 3. 3 is the base. X is the exponent. 3 is the base. Here, 3 is the base. Okay, so if I'm going to graph y equals log of x base 3, that's what log of x base 3, you actually have to do the log button right down here of x divided by the log of 3. That's the only way our calculator will be able to do that. And if I graph it, you can see getting a lot of glare from I replaced the light bulb on my lamp here. I think it's a little too dark or a little too bright. See if that's better. That looks better. Alright, so if I wanted to graph y equals log of x or y equals x, you can see that it goes right through the middle of the two. So logs are inverses of exponential. This is the log, that's the exponential. So if I had the log of 4 base 3, and I wanted to undo the log base 3, you could do 3 to the power of it, because that's the opposite. The log base 3 and 3 to the power are inverses of each other. And I guess we could show that on our calculator. Well, no, I'm not even going to do that. So the 3 to the power gets rid of the log base 3, and we get 4. Just like up here, the cube root and the cube disappear, and you're just left with the stuff inside. Here, you're going to be left with 4. So if it's the log of heart base 7, if I wanted to get rid of the log base 7, you could do 7 to the power of it, and you're just going to be left with heart. Alright, we can undo exponentials using logs. So if I have 6 to the x, if I want to undo the 6, you can do the log of 6 base 6. The opposite of 6 to the power is log base 6, and that would just be x. This undoes the 6, so you're just left with x. Okay, and that's probably still a little confusing. So let's look at another, like an equation. Let's say I have 1 of 8 base 2, and we wanted to get rid of the log in this equation. What's the opposite of log base 2? It is to take 2 to the power. That undoes the log base 2. So I'm going to do 2 to the power of each side. On the left, it'll be 2 to the y. On the right, 2 to the power and the log base 2 disappears, so I'm just left with 8. Okay, so in your assignment and on your quiz, you're going to be asked to write 2 different versions of equations. So the top one right here is just the log form, and this is the exponential form. These are the same 2 equations in just different forms. So if you see a log and you want to write it in the other form, just look at what the base is of each side, and we have exponential form. And if we wanted to go back, if you're given an exponential form and you wanted to create a log equation, you'll be asked to do that. Figure out what the base is. The base is 2, so you have to do log base 2 of each side. And on the left, that will undo 2 to the power, so it'll just be y equals. And on the right, we're taking log base 2 of 8, so it's just the log of 8 base 2, and we're right back where we started in the log form. Log is short for logarithm. Alright. There's one other thing I'm going to show you, and then I'll maybe try a couple. So there's 2 types of logarithms. Log is just the common, or log, log, and then there's something called the natural log. I think this is called common log. That's what I would call it. Or logarithm. And then natural log is ln. And both of those are on your calculator. So there's the common log, and there's the natural log. And if there's no number, like if I have the log of 6 and there's no base there, if there's no number as the base, it's implied that there's actually a 10 there. So if there's no number, there's actually a 10. So the same as the log of 6 base 10. Kind of like if you're taking the square root of 4, well, what number is out front? It's so common to use a square root, we don't even write a 2 every time. We just say square root of 4 is when there's no number there. So log, L-O-G, if there's no number there, it's a 10. A natural log has a base of e, and we talked about e last time. So if I'm taking the natural log of x, it has a base of e, so that's the same thing as natural log of x. Log base e is the same as ln e of natural log. Log base e is the same as natural log. Okay, so natural log is used tons in future math classes. Just like I told you, e will be used a ton in future math classes. For those going on to pre-calc and calc, it's used every day in those classes. We're just getting introduced to logs and exponentials at this point. Okay, so I'm going to have you try a couple problems. So I want you to rewrite the equation. Let's start with that. So number 1, y equals 5 to the x. So write it in the other form. You're gonna write it in log form. And then I'll give you 2. We're given the log form, and I want you to write it in exponential form. Alright, I'll give you a couple minutes to try that. Now, some of you might be out there kind of confused, don't know what you're doing. I'm hoping that more of you understand it than don't understand it. But I'll help you with number 1 so that you could maybe go on to number 2, and maybe 3 and 4 might make sense. So if we want to rewrite an exponential, we have to do a log. The base is 5 here, so we're going to do log base 5 of each side. Log base 5. So then on the left, we're going to end up with the log of y base 5. And on the right, the 5 and log base 5 are inverses of each other. We're just going to have x. These undo each other, so you're just left with x. On number 3, this is the log base 2, so you have to do an exponential on each side, so do 2 to the power of each side. And that'll rewrite it for you. Okay, so number 1 I did for you here, my base is 6, so we're going to do log base 6 of each side. That undoes an exponential. So on the left, we're going to have the log of y base 6, and on the right, that's equal to 2. That undoes the 6. And number 3 here, the base is 2, so we do 2 to the power of each side. So 2 to the y equals x. That gets rid of the log base 2. So here we have to figure out what the base is 4, so we're going to do 4 to the power of each side. So 4 to the y equals, these undo each other, so just 16. So can anybody tell me what y would be equal to? 4 to what power is 16? It's not a difficult question. It's just seeing if you're paying attention a little bit. Nobody's feeling it? I understand. So 4 to the y equals 16, so y must be 2, because 4 squared is 16. So y equals 2. So this is how we're going to end up like solving these problems, like maybe in today's assignment. If you have the log of 16 base 4, we can figure that out by writing it in this form. And we know that 4 squared is 16 because we can write 16 as 4 squared. So then y would equal 2. So what a logarithm is, it's saying the base to what power gives you 16. 4 squared is 16. So this whole thing is 2. I'll give you one more of those for an example. So if I have y equals the log of 27 base 3. If I wanted to figure out what the log of 27 base 3 is, if I just wanted to figure that out, I could set it equal to y and then do 3 to the power. So I have 3 to the y equals 27. Well, I know that 27 is 3 cubed, so then y must be 3. So log of 27 base 3 is 3. Alright, so questions on this? I'm going to give you some time to practice. I'll check in with your teams, and then we'll go from there.